sets also, right?
Yeah.
So there are many types. We'll be dealing with one of the types one by one. So what is this empty set or null set? Do you have any idea?
Like there's nothing inside the set.
Yeah, there's nothing
It's either
inside,
infinite.
no element, right?
I'm sorry, there's no element. Yeah.
So
it's
that
like a
is known
finite.
as
It's kind
empty
of like
set or null
it's
set.
finite, right? Like
Yeah.
it's not infinite. It's finite.
Yeah, no, finite. Yeah. So now,
Yeah.
how do you represent it? An empty set. So that is yeah. How do you remember?
Just like in roster form, I'm pretty sure it's just two curly braces and there's nothing inside it.
Yeah. So this is like you have to represent it by curly braces, and this is a phi, right? So in rooster form, phi is denoted by just a braces, this, right?
Yeah.
So an empty set is a finite set, right? And since the number of elements,
so that in like it says in roster form, there's like a symbol that symbol shows like that's what an empty set is, right?
Yeah.
Like that is kind of that. Okay, yeah.
So like if you can say the example, the set of whole number less than 0. So clearly what we mean to say, there is no whole number less than 0, right?
Yeah.
So that's an example of an empty set, right? So now let's see. So empty sets is obvious. The word only says empty. That means no elements.
Yeah.
And you can write it by phi. It is read as phi, 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 right?
Yeah.
And in the rooster form, you write it with this bracket, right? And a phi inside it. So now what is this? Which kind of set is this?
It's called as
Singleton.
So the second one, like the example one, that's build. I'm pretty sure that's builder's a building set, right?
Which one?
Because like this is such that and okay, so it's a singleton set. Okay.
Yeah, it's singleton.
Because it kind of looks like the building. It looks kind of like the building set.
Set builder form, right?
Yeah, set builder form.
So that is a representation. Set builder form is a representing. How do you represent set, right? So what they have done here, they have represented in this. They have given an example in set builder form, right? But what is the set A? So like this set, singleton set, are those sets which contain only one element.
Okay.
Right? So an example is given. X is neither prime nor composite, right?
Okay,
so that is you just one, the number 1.
Yeah.
So that will be an element of the set A, right? So we can say this set A is a singleton set. They can ask you, they'll give you the kind of set, and they'll ask you which type of set is this A, right?
Yeah.
Did you get? Now let's take the second example. A is equal to.
So A is equal to x such that x belongs to n and x square is equal to 4.
Yeah. So what's the value of x? 2.
2. Yeah.
So the A capital.
Just 2 times 2 is 4.
Yeah. So now the element of capital A is what? It's just 2. Only one element. 2. It's only one element.
Because it's a singleton set.
Yeah. So capital A, the set A is a singleton set, right?
Yeah. So it equals to 2, right?
Yeah. Now what is this infinite set? The word infinite is clearly shows what?
Yeah. So basically, infinity number of numbers in the set. Like if they ask you, tell all the numbers greater than 0, you get infinite numbers.
Yes. So some few examples are given. Set of all points in a plane. They can be infinite number of planes, right? Set of all prime numbers. That is also an infinite set, right?
Yeah.
Now the cardinal number of a set. What do you mean by the cardinal number of set? Cardinal means the number of distinct elements in a given set.
Is a given set A is called the cardinal number of A.
Yeah.
It's
if I ask
denoted
you,
by.
If I ask you, A is this set. Now, what is the cardinal number of this set A? You have to count the number of elements. 1, 2, 3,
So the number
4.
of elements in the set is the cardinal number.
Yes. And how do you denote it? It is denoted by n bracket.
Okay, n of A is equal to 4.
4, yeah. So like you can see, this is a set B and the set of letters in the word algebra. So they have written out in the rooster form. Now they are asking you find the cardinal number of this set A. So that is, you have to count the number of elements. 1, 2, 3, 4, 5, 6.
6. So n of B is equal to 6.
Yeah. So that is the cardinal number of a set. So in some of the problems, they might be asking you for find. They will give you a set and they will say, now tell me what is the cardinal number of this set, right?
Which set?
Any set they can give you.
Yeah. Oh, okay. I thought you were asking the question. Yeah.
Okay. Now the equivalent sets. What do you mean by equivalent sets? Two sets are given, A and B, and now they are said to be equivalent if the cardinal number is the same, right? And this is denoted by this symbol, right?
Okay.
So that means if I write like this, A and B are two sets, and I use this symbol. So this means A and B are equivalent, right?
Okay. Yeah.
So next, so you can see these are, an example is given, A is given, B is given. Yeah, cardinal of A is 3, cardinal of B is
cardinal
3.
number is.
So A and B are equivalent sets. You
Okay.
can't say
so
equal sets. No, it is equivalent. Equivalent means what? The cardinal number has to be same for both the sets, right? Now equal sets. Now what are equal sets? Two sets A and B are said to be equal if they contain the same elements, right? Equal means same.
But they could be like random, right? Like if it's like I can write 1, 2, 3, one set is equal to 1, 2, 3, 4, and other set could be 4, 3, 2, 1, but still both of them will be equal, right?
Yeah, all the numbers are same in that, right?
Yeah, exactly.
Right, you can see on this A is equal to B. So the elements, if it is same, it is equal sets. And if the cardinal number is...
like if both of them are equal, then automatically the cardinal number will be the same, right?
Yeah, that is there.
Yeah, so if like two sets are equal sets, the cardinal number will be the same.
So automatically,
all the time, right?
You can say it's an equivalent set, right?
Exactly. Yeah.
Now what are disjoint sets?
Two sets A and B are said to be disjoint if they don't have any element in common.
Yeah.
So no element in common.
Yes, no element in common. So that is known as a disjoint set, right?
Okay.
So this A is a set which is a prime number. It consists of elements X, which is a prime number. B is a composite number. So obviously no elements are common. So the opposite,
yeah.
Yeah. So it's a disjoint set.
Yeah.
Now overlapping sets. Now what is this overlapping? A and B are said to be overlapping if they contain at least one element in common, right?
Okay.
If any one of the element is common, we say A and B are overlapping sets.
Okay. So if at least one element is same,
so
it's
an
called
overlapping
sets.
Yes.
If it's more than one, it's still called an overlapping set.
Then also it's an overlapping set, right? So you can see with this, A is A, B, C, D, B is A, E, I, O, U. So now A is common, right? One of the element is common. Yeah. So I can say A and B is an overlapping set, right?
Yeah.
Next, what is subset?
The definition of subset: if A and B are two sets, and every element of set A is also an element of set B, then A is called a subset of B. So every element is there. So they're basically equivalent sets, and they're called subsets, right?
That is but it's not a necessary condition like all the elements should be same.
It's not. Yeah.
Right?
Exactly. Yeah.
So we have two sets A and B, right? And every element of A is also an element of B, right? Then
but
A
doesn't that make them equal all the time?
Yeah, if they are equal, then you can say A is a subset of B. If
No,
all
like
the
it says but like it says every element of set A is also an element of set B.
Yeah.
So that means if if A has 1, 2, 3, 4, B will also be having 1, 2, 3, 4. So that makes them equal, right?
Then
so
it becomes equal. Yeah, but
yeah.
okay, then you can say that both are equal set, right? But you can say A is also a subset of B. Because So now let us suppose here you can say it's a subset is denoted by this symbol, right? So you should be very careful, right? This way. So that is A is a subset of B, right?
Okay. I have a question. So example, A is it has 1, 2, 3, and 4, and B has 1, 2, 3, and 4, and 5. Will they be subset?
Yes,
or will
obviously
they not?
A will be subset of B, and B is known as a universal set, right?
Okay.
So this is
B won't be subset of A. Only it's only A is subset
A is a
of B.
subset of B. Yeah. You should be careful.
So it won't be
that.
B is subset of A. Okay.
Yeah. So it is denoted by this sign, right? This is known as a subset of, is contained in. A is contained in B, right?
Yeah.
If you are writing this way, what does it mean?
B is subset of A.
Yeah, B is in A, right?
Yeah.
So you should be very careful where you are putting the sign. If it is this way, that means A is a subset of B, right?
Yeah.
And if it is
in the
this
second
way,
in the statement it says if you go up in the first statement, the first bullet point, both of them are the same, right? Because the symbol the first bullet point.
This one. Okay.
Yeah, both are the same thing, right? Because that
A
one's
is a
facing
subset
that
of
side,
B, so they have just replaced it, B and A. This also indicates that A is a subset of B.
Yeah,
it's the same
exactly.
thing,
okay.
Right?
Yes, same thing. Yeah.
It's the same thing. But see this one. This is different.
Yeah.
B is a subset of A.
Instead of A. And then the other one is A is a subset of B.
Yes. So now what it should is that the symbol, if it is this way, it means if I say A and B,
A is
so what is
subset
this?
of B.
A is a subset,
of B.
Yeah.